Our terms are labeled. I'm just going to write it off top in a second. Okay, so what that says is our terms are labeled T1, T2, T3. And I apologize, I'll try to write the T's here instead of printing them because they look like pluses, but actually use T's though. So they're labeled T1. T1 is the first term. T2 is the second term. Somebody please tell me what T11 means. The 11th term, very good. Now, you might say, Mr. Sadler, I got it, okay. But this is really important because when it says T11, we don't get some information from that. Tn has a special name. That's called the general term. It is the nth term in the sequence. And it's also the equation to find any term in the sequence, right? So if I give you the general term, which I'm about to here, you can find any term that you want. So what I'm going to do is I'm going to take you through the first example, then I'll give you guys a little chance to work and try this out. Okay, so this is just no time, so I'll do example 2. Example 2 says, determine the first 4 terms in each sequence. Okay, so letter A is going to say n equals 3n minus 1. So that is what we consider to be a general term, 3n minus 1. Okay, that's the equation that I'm giving you. Okay. If I say to find T1, Jake, Jake, any idea of how I find T1? What would I do for that? Any idea? Yeah, 1 for what? Good, very good. All this means excellent. This means set n equals 1, right? So T1 is just going to equal 3 times 1. Does everyone see that? The subscript is n matches the variable in the equation. Any question on that? Right, so the subscript n matches the variable in the equation. That's what it is, right?
Well, I'm just curious about like.
Okay, so our regular equation just says that t small, like subscript n is equal to 3n minus 1. So this is T1. So all I'm doing is replacing the n in my equation with whatever the second happens to be. So this is then okay. Yes, so this is then T1 is going to be 2. Now this is the beauty of these equations, okay? Morgan, let's say I were to ask you to find T81. Now that sounds hideous. Doesn't that sound evil? How would I find T81? 81. That's the beautiful thing. Once you have the general equation, you can find any term you want. We have 243, 242. Unfortunately, that isn't what our question's asking us today. What's the question actually asking us? The first 4 terms, okay? But that's by just showing if you need the 81st term, that would be that. Okay, how to get T2? William, T2 is going to be what? Good. Lovely. Caitlin, T3, what do I do? Good. Good. T4. Good up to Gary. By the way, my wife daughter loves the slippers. Jack has no interest in them right yet, but you can tell your mother I'm interested in the class. Like she wore them so much. You know that big red ball that was on top? One of them started falling out, so I had a little red all over my house there. But she loves them. She loves them all the time. Anyway, enough with that. T4, go ahead. Sorry, the internet didn't need to hear that either. Go ahead. Good. Now you're really saying, Mr. Sadler, I got this. What are you taking such a long time for this? I want to show how the patterns work here, though. Like this has got to be automatic here for the end. What do you notice about those numbers 2, 5, 8, and 11? Joe, what's you notice? Yeah, we go up by 3 each time, and that's what we're going to start to show. The slope would be 3, looking at it that way. Okay, right, and this is taken as a linear function, right? So 2, 5, 8, 11 is linear. And a little bit. Okay, I want you guys to do B, C, and D for me right now. B is going to be, I'm going to make this easier for you. I'm going to say, find T5, T6, and T12 for the following. The first one's going to be Tn equals 5n squared plus 3. Tn equals -4, Tn minus 1, and 2n equals n times n minus 1 over 2. All right, I'm going to hit pause. I'll give you about 5 minutes to get those done, and then we'll take them up here, okay? Okay, Sabrina says 128, so it'll be T. So T5 is 5 times 5 squared plus 3, which is in fact 128. Pardon, can I get the same thing for T6, please? 183, so it's 5 times 6 squared plus 3 equals 183. Here we go, Maddie, go ahead. T723. Lovely. Those are the 3 nice ones. I don't want up the front here. I don't want up the front here. Okay. I know, but you gotta keep answering. Okay, you're gonna eventually. We started there. Okay, go ahead. 2, 5, 6. The negative 2%. Well, it's not there. So this is going to be T to the 5. Oh, Tn equals -4. And minus 1. Sorry about that. You said positive. Okay, so I'm going to say, we'll find it right now. It'll be T5 is going to be -4 to the 5 minus 1, which is -4 to the 4, which is going to be positive 2 to the 6. Okay, right? It's a negative number with an even exponent that turns to positive. Okay. Now again, if you need to show these steps, do it. No offense, I'm looking at Liam's page sheet. It says all the right answers and all is good. Okay, right? But just for the, especially at the more complicated ones, like 2 and 3, no more difficult. All right, go ahead. T6 equals. 1024. And again, I know that's right without even doing all this work, because if this is right times it by a -4, that's what you get. Janet, T12 is a big number.
-41943.
That's a big number. Can we confirm that? Yeah. Lovely. Okay. All right. The last equation was monster was n equals n over minus 1. Okay, I need all these answers in fractional form. Okay. Go ahead. T to the 5 equals. Sorry?
I got it wrong.
Oh.
1.42.
Okay. Okay, I'm just going to slow down here.
Sure.
I didn't mean to shoot you down. What I meant to say was, please leave in fraction form always. What'd you say, Heather? 20 over 14? 20 over 14, which, yeah, lowest term is 10%. Now, I'll talk a little later in the course of time why that's my favorite fraction, divided by 7. Please always leave as a fraction. Now, how they got that? 5 minus 1 is 4. 5 times 4 is 20. 2 plus 5 is 7. 2 times 7 is 14. Okay, good. So you were right, but you decided that's okay. Nate, back to you somehow. Go ahead. T6 is equal to what?
30 over 16.
30 over 16. I said you're half right. Yeah, so I call it 15 over 8. How he got that, I hope, was something like 6 times 6 minus 1 all over 2 times 6 plus 2. Okay, Amy, T7.
33%.
33 over 7.
Well, the first part is like 132.
132 over 28, which is 33 over 7. Okay. 132 over 28, which is 33 over 7. Okay, I'm going to show how we got that in terms to 7. Oh, that's 12. Oh, 56%. Almost have been up every night for the last 2 weeks. Here we go. 2 over 12 plus 2. Okay, so 12 times 11 is 132, and 12 plus 2 is 14 times 2 is 28. Good? We're feeling somewhat okay with this, because now I'm going to make it worse. Okay, actually, I'll stop before I make it worse. By the way, all my students in all my class, they'll tell the joke.